Hello, this is Dr. Grafton, and this video is going to be about assignment 2.5, the probability case study. Uh, Probability is indicating the likelihood that something may or may not happen. And we use modeling and simulations to help us make business decisions based on the probability of that event occurring or not occurring, okay? So in this particular case study, then, we're going to be using an Excel spreadsheet that's going to create a simulation of 1,000 scenarios. Each scenario basically is going to be a row in the spreadsheet. Um, the spreadsheet that you download already has some embedded formulas in it, but you're going to need to complete that spreadsheet, and you're going to have to enter some formulas of your own. Basically, we're looking at a bicycle manufacturer, a particular bicycle that they're making. They want to be able to manage the inventory of this bicycle, and it gives us some information on that. There's like 1,000 units that are going to start the year off. Um, the demand each year is going to change, and we to store the bicycle each year it's going to be $50. If there's an excess of demand, it's going to cost us $80 extra per unit. And we're going to go through those simulations using a average of 1,000, or the mean, and a standard deviation of 75. So let's go ahead and look at the Excel spreadsheet then. So this is what you'll see when you download the data file. You have the blue boxes, which you're going to enter the data from the assignment that we were just talking about. You'll see these here are give you an error message. Well, it's giving you an error message because you haven't completed the blue boxes yet. The formulas have already been embedded there for you. If you saw, I just went up, I'm in the formulas tab, went over to click show formulas. And so it shows you the formula that is going to be required for this table. So what we'll do to build this out then is we'll go ahead and let's hide the formulas. Let's enter the information that they gave us from the assignment. So you've got initial inventory of 1,000 bicycles. You've got a storage cost of $50. You've got an additional unit shortage cost of $80. Okay. The mean then for normally distributed demand is 1,000, and our standard deviation is 75. Okay, so now we have the first um, simulation done. Excuse me. We're going to do this 1,000 times, so we need to copy this down 1,000 to 1,012. So this is, to me, the quickest way to do it. There might be other ways to do it. As you see, it's going down pretty fast. You need to kind of keep your eye on the row numbers as we go down, because it's going to come up here. There it is, 1,012. Once you let go of that little handle there, it's going to complete all the different scenarios, and there's 1,000 scenarios there now. Okay, so now each time we click on F9, you can see the information is changing. See, that's our simulation. So now we're wanting to look at the next part of the assignment. It says find the expected annual cost associated with potential shortages or surpluses of this product. Okay, so here we have a shortage cost and a storage cost. Okay, so we're in G, column G. So we're going to enter a formula here to give us that. All right. So we're going to go in. We want the average storage cost for all the simulations. So it's equal average. And so the storage cost is in column B here. So we're going to click on that, and just like we've done before, Control Shift down arrow, and that gives us the entire column all the way down through 1,012. Hit enter, and then it gives us what that average storage cost is. The average shortage cost then is similar formula, equal average. We go over to the column that has the shortage cost, highlight the first one here, Control Shift down arrow. It gives us all that, hit enter, and we can go back up and see that. Now we want to sum this, so it's equal sum, highlight these two, close print, there we go. Oops. I fat fingered it, so hit 0 instead of close print. So it should be 14 colon G15. All right, you notice every time we click on something, the simulation changes. So there's not going to be a set answer, but what you'll need to do is just cursor through this several times and start to see if there's a pattern. Is there like a high and a low, and is the totals very similar? Okay, so that's you want to be able to watch that because it's going to want you to explain that later. So we want to look at the two annual total cost levels, and is there an equal distance from the expected value found in part 1 here, such that 95% of all total costs associated with managing the potential surpluses are between these two values. Okay, so what we've set here is a 2.5 percentile. That's not 25%, but that's 2.5%. And then a 97.5 percentile. Okay, so we're looking for values going between those two. So again, we're going to use an embedded formula called percentile. So we ERCEN, so there's percentile. You double click on it and it gives you the tooltip there. So it wants to know the array. So now we're going to go over to D, and again, Control Shift down arrow, and that gives us, I hit enter too soon. I got to go back and give it the percentile. That gives us the array, but we haven't finished the formula yet. So comma 0.025, there we go. Now we hit enter. That's 0.025 is 2.5 percentile, okay? So that gives you $200. And again, you notice every time I hit enter, the numbers are changing. So this simulation is not going to have a static answer. You're just going to have to look at, see what types of trends every time you run the simulation. So the next one then, we want to do the same thing, percentile. We want to go back over to total cost again, Control Shift down arrow, go back up to enter the 0.975 to finish the formula, comma 0.975, close paren, and hit enter. Okay. So the assignment now is asking you to continue using the simulation, and you're trying to see what type of patterns might be going on here. So every time I hit F9, it's going to do the simulation again. But you'll notice that you'll be able to interpret some of this data from there. Like, you know, what is the, are these shortages going to be between, and the shortage cost and the storage cost going to be between these two percentiles, okay? So you can make comments on that. So in part 3 then, what it's wanting you to do is comment on the annual production policy in light of what you find in these two simulations, okay? So now that you've built the simulation, you've run the simulation, like I say, each time you hit F9, it's going to run the simulation again. You'll be able to make some kind of analysis, and that's what you would write in part 3, okay? I hope this helps you with the assignment, and good luck.